Hello and welcome to another one of these ADD videos. Today we're going to be discussing library functions and transformation rules. These are basically some functions that you're going to need to memorize, some functions that you'll deal with often. So just take the time to memorize these. Y equals X is a straight line. I promise you that's a straight line. That's about 45 degrees from the x-axis or y-axis. Y equals x squared, probably should be familiar with that one. Then we have y equals the square root of x, cube root of x. Just basic shapes is what we're looking for. Like technically, what layer is that? That's layer 3. This one right here. Misbehaving. Technically layer 3, we shouldn't be reaching 2 until we get to 4, right? So it should look more like this. Oh, wrong color. Something like that. And then the cube root of x, kind of S looking thing, absolute value of x. Okay. Then we have 1 over x. Right, these are all functions you're going to need to memorize. That's also x to the 1/2, x to the 1/3. Absolute value of x. 1 over x. And this one's the greatest integer function. Basically the way this works is it's -4 on your y value when x is -4, but the moment that x becomes -3, it jumps up from -4 to -3. And it's -3 until x remains -3, but the moment that x becomes -2, it jumps up to -2, so forth. Okay? So with these basic functions, there are some transformation rules that can be applied. So if I had something like this, and I had square root of x, for instance, plus 4. Well, you would start at 4 and you would draw that basic shape of that, which is the graph of the square root of x. Because the plus units move them up plus units, plus c units. So whatever the c value is, then you move it up that many units. In this case, c was 4. If it was -3, whatever, same concept. Okay. Now, if it's inside the parentheses, what I tell people to do is don't just use the opposite rule. A lot of people have used the opposite rule, and it works most of the time, but doesn't whenever the coefficient of x is -1. So what I do is tell people solve for x, set it equal to 0, solve for x, and if your answer is positive, move that many units to the right. If your answer is negative, move that many units to the left. Okay? So for instance, if I had something like this, let's look at this example. Y equals root x minus 4. In this scenario, yeah, it would work opposite rule. So -4, if I set that equal to 0, and add 4 to both sides, I get x equals 4. So what that tells me is what once was 0 is now at 4. So I would graph starting at the x value of 4 and put my square root of x function there. Okay? Always set it equal to 0. I try to use fail-safe methods in solving these. Again, if you encounter a negative sign, then it would move to the left. And I guess you could use the opposite. That gets a little confusing, just try to remember solve set equal to 0. So the two reflection rules, if I gave you negative inside the parentheses, but flip it that way and reflect it about the y-axis. Okay, but if I have a negative outside the parentheses, well, I guess I could do that in a different color. What that would do is it would take the original and flip it that way, upside down, about the x-axis, this being the original graph in green. Okay, these are all rough sketches, so you're just supposed to get the concept here. So now, what happens if I have a numerical coefficient? So, oops, wrong color, sorry about that. So if a is greater than 0, we're going to get a vertical stretch and a horizontal shrink. And basically what that means is your y value is getting multiplied by a number greater than 1, so it's going to get to infinity faster, if that makes sense. It's getting larger quicker. So what was the point 4 comma 2, for instance, in the normal graph, which I'll do in dashed lines. Let's say we look at the function y equals 3 root x. Well, that point that was 4 comma 2 now, and that's not a cube root, that's the 3 times the square root of x. Now it's going to transform into what? Well, the x value would stay the same, but the y value now is 6. So instead of being this 2, we'd be up here at 6. So you can see how vertically we've stretched it. Okay, and when we stretch it vertically, what ends up happening usually is you get a horizontal shrink. It's kind of hard to picture with the square root of x, but if you want to use x squared as your example for this one, it probably would show up a little bit better. Actually, you know what, I'll go ahead and do that for you. So let's look at x squared. The general parabola, if you remember from earlier in the video, is this. Well, what happens if I take that and oops, parabola is x squared, sorry about that. What happens if I take that times a 4? Well, the y values now are going to shoot up a lot faster to infinity, because they're 4 times what they were. So you can see that when a was greater than 1, what happened? Well, we had a vertical stretch, meaning we pulled it longer vertically, and horizontally we shrank in. We moved in this way. Okay. Whereas if I had multiplied by a fraction, it would have made it lay down a little bit fatter, and the opposite would have happened. Okay, so I forgot to write it down here. It was a vertical stretch and horizontal shrink. this is in our scenario of a being greater than 1, but if it was less than 1 but greater than 0, then it's going to be a vertical shrink. You can literally see it getting flatter. And a horizontal stretch. Okay? So, memorize those graphs. Practice your transformation rules. On the test, you're not going to see just one of these applied at a time. You're going to see all of them applied at the same time. So be able to go from a base function to a more complex version of that base function. Okay, so again, greatest integer 1 over x. Don't forget the absolute value signs. I'm sorry, the asymptotes. It's early in the morning. I apologize. Absolute value of x. I was getting ahead of myself. X to the 1/3, square root of x, x squared, and x. All right? I hope I've clarified things. Practice, practice, practice. Thank you and have a nice day.